Good morning, students. Before I start today's class, let me remind you one thing, that whatever we have studied in the previous video, you have to copy the notes given in the video in a rough copy. These notes will surely help you in the regular classes. So I request to you, please go through the previous videos and please copy the notes which I have given in the previous videos for your future purpose. In the last class, I have explained you about electrical circuit. I have told you that in an electrical circuit, we represent different electrical components with the help of different electrical symbols. Today I continue the same topic and I take up the next topic, which is electrical symbols. The definition of this topic is: many different kinds of equipments or components are used in setting up electrical circuits. To draw the diagram of electrical circuit, we must know the symbols of components of commonly used in the electrical diagram. Electrical symbols for some commonly used components are given here. So I have drawn some of the components diagram here, and the diagrams are given here. The first one represents a cell. The bigger one is the plus and the smaller one is the minus. Second one is a battery. Battery is a combination of cell. When we arrange two or more than two cells, then we get a battery. Look at the combination. Last, starting from here plus and ending is minus. The third one represents a bulb, then resistance. Fifth, variable resistance. It is also known as rheostat. And the seventh one is key, which you normally say as a switch. So I have taken some of the example of the electronic components and their symbols. We have got many symbols which you will find in the NCERT book. Now, I take up the next topic, which is a very important topic for your board examination, and the topic is Ohm's law. It is very important for your future examination. So let me explain this law. So first we must know about Ohm. A German physicist, Georg Simon Ohm, established a relationship between current, potential difference and resistance in an electrical circuit. This relationship is known as Ohm's law. That means he was the scientist who created relation between current, potential and resistance. Now he gave us the Ohm's law. And the statement is as follows: at constant temperature. This is the most important technical word you have to remember. At constant temperature, the current flowing through a conductor is directly proportional to the potential difference across the conductor. So whenever you define the Ohm's law, this is the most important thing, that the temperature is kept constant, and then we are going to create a relation between current and the potential difference. So let I represent the current, V represents the potential difference. So on the basis of the statement, I can give a relationship I is proportional to V. In mathematics, I and V are considered as variable. And so I can say that V proportional to I mathematically, this is a very important thing, that this relationship which I'm getting here is a mathematical relationship of the Ohm's law, where I and V are two variables. And so we have written the statement V proportional to I mathematically. Now, as we know in our class 9, that whenever we remove this proportional sign, we are going to put the equal to sign and a constant. Here the constant is R, and this R is known as resistance of the conductor. R equal to constant called resistance of the conductor. Now this formula is known as the mathematical expression of Ohm's law. So if the question comes, state the Ohm's law, we are going to write down this statement. And if you have to represent the mathematical relation between the three variables, then this is the relationship here. And in that, R is the constant. Now to verify this law, we have the experimental verification of Ohm's law. This is also a very important topic. For conducting this experimental verification, we have to take certain components. So look at the circuit diagram here. This is a resistor. This is a voltmeter connected in parallel. These are the connecting wires, ammeter, cell, variable resistance, and a key. This voltmeter is connected in parallel, ammeter in series. Now you can see a dot mark here. That means the circuit is closed. That means the current is flowing. And look at the direction, plus to minus. So when we switch on this circuit, we will get the readings of the voltmeter and ammeter, and we will copy the reading in the table like this. First serial number, then current, then potential difference, and then the ratio V by I. After getting the first reading, we will switch off the circuit. We will change the variable resistance value, and again we will switch on the circuit. And after switching on the circuit, we will get one more reading of ammeter and voltmeter, which we will copy in the table given here. Now look at the table here. I have taken one example there. I have taken three readings. In the first reading, the current is 1 ampere. Potential difference is 2 volt. So ratio is again coming as 2. I have performed this by the help of three different values, and look at the last column. Each and every one has got the same value as 2. And that proves the Ohm's law, that the ratio of V by I should be constant. So this is the arrangement of the Ohm's law experimental verification. On the basis of the data which we are getting here, we will draw a VI graph. And in this graph, the V will be in the y-axis, I will be in the x-axis, and the graph will be of this pattern, directly proportional nature graph, and the slope of the graph will represent the resistance of the conductor. Now this part of the question has to be explained properly by you. Now in the given assignment, you have to write it by your own words, the experiment which I have just now explained, and then you can give it the table like this way and the graph in this way. So thank you for today. Just before ending, I can only say the topic which I have taken today is a very important topic, and I request each and every one to go through this topic properly. In the next class, I will be starting from this topic so that I can clarify your doubts. Thank you and have a nice day.